Welcome back to Ox Tools. I'm Tom. So we got another batch of meatloaf. Got some interesting stuff here. We've got microtome knives. We've got a package from Ukraine. We've got a artillery clinometer and I don't know, tuna can openers, all kinds of stuff. So sit back, relax, and have a nice batch of meatloaf on me. This one here is from a friend of mine in the Chicago area. This is from Dennis P. And I've known Dennis for, geez, quite a while. Oh wow, I didn't even know there was something inside there. Look at that. That's bonus. I didn't even know these were in there. So he watched the tuna press build with great enthusiasm. And he said, "Oh my God, I can't believe you're using that lame ancient can opener." So what he did was he sent me this hot whammy can opener here, okay, and this is Kuhn Rikon, Swiss made, so it's probably pretty spiffy. And I've seen this type before actually, and the cutter wheel on this particular type actually cuts through in this axis here, and there's a couple of side benefits of that. Here, let's peel this tape off here. Is the lid doesn't go down inside your stuff. Okay, that's one advantage. I should have prepped this beforehand here. He's put some buddy pulls on there. That's what we call those. So, and the other, let's take this out. The other deal is this goes back on and it kind of stays on, and which allows you to use this for, like, you know, clean. You could have a solvent in there or something like that, and or oil or something like that, and you can kind of reuse the lid. And you know, for you super cheapskates out there, you can make this into one of those oil cups and re-solder that or glue it in there or whatever. I don't know what. So, and I had no idea this was inside. I just discovered this. Dennis has a 3D printer, right? And like a lot of 3D printing junkies, he's oh God, what do we got going here? Dear me, I don't even know what we're doing here. So, you know, this is a pusher of some sort, I suppose, right? And but that's the whole problem with this, is you got to use your hands, right, to squeeze the stuff, and was the thrust of the idea behind the tuna press there. Okay, the tuna dewatering press. But let's take a look at this thing. This thing's pretty spiffoid here. I love this handle, right? You know. Now, I have no affiliation with these guys. It's just I can appreciate good design. So the handle's very nice. It's got a good size. It's got just the tiniest bit of texturing on it, not so much that it interferes with cleaning, but it gives you a little purchase. And then this handle gives you supreme purchase for leverage here. Oh, look at that, it's even kind of spring. Oh, okay, that's part of the function. So that it cams in and then engages with the lid, and then you cut. Now this little thing here, this little chomper on the side there, I am not clear what that's for. Oh, okay, that's cool. I just saw something else here. So this guy here is for pull tabs. You know, like sardines, right? You know, those little the little rings. You can get onto those little rings, and you can get a little more leverage on that. Okay, so they're covering all the bases here. So yeah, I'd have to say that's a nice looking unit. So now it's got me going here. What is that little Chingus for? Use mini pliers. Push button to lift fully. Okay, so. It's for grabbing this, so you don't have to grab the edge or whatever. All right, mini pliers. Anyway, Dennis, thanks for sending this stuff. Much appreciated, and I'm glad you liked the video. And he sent me a recipe for salmon salad sandwiches with capers and pickles and stuff, and it sounded really good. So I'm gonna get some salmon in a little can like this and try it out. So thanks, Dennis. Well, we were just talking about this little hook here, right? A little pull tab, and I got a box that showed up, mystery box that showed up, and it had a whole bunch of Ox Tools swarf-free tuna in it. So this is from my friend out in Rio Vista, Gary Brown, and he sent me his favorite, which is with the pull tabs here, and which is exactly what this thing's for here. I don't want to pop one, but that's the idea, and then you can open that up. So this is Old Iron Machine Works. He's got a YouTube channel. If you haven't checked him out, go check him out. He's out in Rio Vista, which isn't too far from here. And he collects and restores old machines, mainly collects. He's got quite the iron collection. And anyway, he sent me some tuna with pull tabs. So a lot of people got a kick out of the tuna can dewatering thing. So I guess I'm getting slammed with tuna. Anyway, thanks, Gary. Appreciate it, and we'll see you soon, pal. All right, this one comes to us from a gentleman that I've corresponded with a bit, and his name's Rob Phillips, and he is, I guess, is he the owner? I believe he's the owner of Buckeye Brass and Winds. So they sell horns and musical instruments. And the interesting thing, I've kind of bumped into him because some of the metal work involved in making musical instruments is actually pretty interesting. Here's a good example. How do they polish all that stuff, right? And all those, this is all soldered together and fabricated, from kind of raw brass sheet, right? And they got to polish them when they're done. And if you've ever looked at one up close, the polishing is actually quite nice. And anyway, they have some tricks of the trade, and they use these ropes that have polishing compound in them, and they have just kind of an arsenal of different little tools for getting that done, which, and that's how I learn stuff, is I watch other people doing things, and, you can take ideas from one trade and apply them in another. I kind of like that kind of stuff. So anyway, Rob, he sent me some goodies here, and this is the first one here, which is some ephemera here of the Wizard Chuck, and I think I catch the parallel there. And this is some kind of, and I've never seen one of these in the flesh here, but it's some kind of quick change chuck. It has a Morse taper on it, but some kind of adapters with a bayonet key locking arrangement here to insert the tools in and out rapidly, which, there's quite a few different systems like that. And this is one that I haven't seen. Now, clearly it didn't become super popular. There are some other systems that, and I can't think of the names right now, that were more popular. But this is neat. The fonts on here are kind of old-timey here. I mean, look at this figure 3, figure 1. The way this is drawn, this is kind of old school. It's got that kind of lithography look to it, which is kind of neat here. And this is the oh yeah, okay, Meadville, Pennsylvania. All kinds of good stuff going on there. That area, honestly, I don't know what's going on in Meadville. A lot of deer hunting, I know that. And but Merkin's Tool is there. I think there's quite a few tool and die shops there. So I'm not sure what is around Meadville that attracts tool makers, right? Or tool manufacturing companies. So that's kind of an interesting coincidence. So anyway, he sent me another thing here too, which is kind of neat. Let's get this out. And this is kind of cool here. It's a artillery clinometer is what this is, and it's just glorious. It's just super nicely made. It's made out of brass or some kind of bronze. What do I want to say? It doesn't look bronze. It almost looks nickel silver to me, right? That's what it kind of looks like here. It's non-magnetic. Okay, that's magnetic. That's a steel rivet there. But let's get in a little closer and we'll talk about this and the scale on here and how this thing is used. So there's a better view of this this really nice instrument here. So actually, let's just take it out of the box here. I mean, anything that comes in a box like this is, look at this, that's just a spiffy box. And you see this, 1 divided by 6400, that has some meaning here for us. And this is a clinometer, clinometer, clinometer. So it's used for measuring angles. And this particular one is used for setting the angle on artillery pieces, and it has a little bubble level in it, so that you can set a particular angle, like so, and then you put it against the gun or set it on the gun, like so, and then you adjust the gun until you get your bubble centralized like that, okay, and then you know that the gun in relation to gravity is at the correct angle, okay? Now, what's weird about this one here is, and I'm not completely clear on its operation. So, a circle has 6,400, this is a military mil scale, MIL, which stands for milliradian. Thousandths of a radian, okay? And so 1,600 mils is 45 degrees, and we see that down here in the bottom here, right? So that would mean that this would be the measuring surface here in this case, right? Which doesn't make any sense to me, because it's a skinny little edge, and it's clearly kind of set up for this to lay on the artillery piece. At least it seems like it. Now, I kind of poked around. I couldn't find any pictures so of this one of these in use, although there was a lot of these pictures of these. And this one's pretty cool in that it has a real fine adjust here, okay? And we can adjust the angle. And then it has this little adjustment here for the level. It's got a little key here. Let's go ahead and do that, and then you can see that move. And you see that's moving in an arc like that, right? So this is a vernier, whichever you like, okay? I don't really care. And you can make very, very small adjustments there, which is pretty neat, okay? And plus and minus. So kind of cool. So why a mil scale? What the milliradian scale? Why would we want to use that, right? Well, the interesting quality of radians like that is if you have a known distance or a known height of an object, you can calculate distance or you can calculate size just by looking at it. So a lot of military binoculars have or scopes have a mil scale in it. So if you see something at 1,000 meters and it's subtends 1 mil, then you know that object is 1 meter tall, okay? So it has this interesting quality that very easily you can determine distances or sizes. So meters over mils times 1,000 equals that's the equation, I should say, and then you can rearrange it depending on if you have size or you want to know distance or vice versa. Okay, I hope that makes sense. That wasn't a very mathematically rigorous explanation. And this is made by the Franz Kuhlmann, and this was made for the German Army. Okay. And I don't know if, I think Kuhlmann is, that may be Swiss, I'm not positive. But here's our clue here, is it's got the little eagle on it there, the evil eagle. And although you can't see into the little circle of the eagle there. So kind of an interesting historical piece used for measuring angles and setting artillery pieces. So just kind of a, I don't know, I love these old instruments. I mean, this thing weighs like, I don't know, probably weighs a kilo or something like that, a couple pounds, and it's just beautifully made. And all the pieces are here, all the knobs are intact, and a lot of times the knobs are missing on stuff like this. So Rob, thank you very much for sending this. This is pretty sweet, and that's just kind of a nice piece there. And maybe we'll look at another type of clinometer that's used for setting and measuring angles. So we got a little repair job here for one of my car neighbor buddies, and these are I don't know, rear bumper chrome strips. I don't know what the proper name for them is, but basically the tail light goes here, tail light pokes through this, and the lens mounts on these little studs here. Now this is a I don't even know what this is made out of, honestly. Zinc or something, it's some kind of casting. And let me show you the problem. This is the problem one here. And you can see that somebody got medieval on this and kind of blew out those threaded posts there. Now, this isn't weldable. That would just not be the right approach here. So what can we do, right? I guess is the question. And so there's some complications here. These kind of come out at an oddball angle. So your first thought might be to just whack them off and put a new stud there and attach it in from the back, right? And but getting it to sit at that angle, because it's okay, there you can see it there. It's not normal to this mounting surface. That makes it a little tricky, right? So I kind of noodled it and looked at it a little bit and tried to think of a way to fix it. So fortunately, we have one good example. So this one's healthy here, and hopefully you can see this on camera. As these are tapered, and this is needed to release it from its mold or whatever, with the permanent die casting or something like that. So we can get a good measurement off of these studs here. In fact, let's just do that right now. Let me get this one out of the way. Get some pip here and some calipers. So what I'm going to do is first I want to get some diameters, diameter at the tip, and then I'm going to measure down, say, an inch or something like that, to see what this taper is, because I want to duplicate that taper. So what I'm going to do, I don't drop all my Sharpies here, is I'm going to cut this off, or the bad one. I'm going to cut it off down here and replace the upper section with a new tapered piece. And then we'll thread this section and we'll thread this section and we'll put them together with a little stud with some Loctite on them, and then we'll have our female thread here at the right spot and at the right angle, and it's all perpendicular cuts and everything, so it's easy from a kind of a machining standpoint. So let's mark this off. Oh wow, look at that. Hey, sometimes you're lucky, right? That line is exactly at 1 inch. All right, let's see here. What is that? 340. So everything starts with a little sketch here, right? So this diameter here, 1.0, is 342. Okay, now we'll measure it at the tip here, that diameter. Let's see what we got. And this is always a little. .283. Okay, so from that we can determine, we got a little angle here, right? We got a little angle here that we have to deal with, and so let's figure out what that is. So 342, 283. Okay, so it's about 60 thousandths difference in the diameters between the big end and the small end. Okay, so what I care about is, since we're going to machine it, I care about the half angle, right, not the included angle. So let's see, what can we do here? So let's take half of that. Let's divide that by 2. Okay. So that's about 30 thou, something like that, okay? So 30 thousandths over 1 inch, okay, is a little less than 2 degrees, okay? And you might be wondering how I know that, right? Well, if you keep one thing in your head, the sine of 1 degree is 0.0175 inches. At 1 inch. So over an inch, 1 degree is equal to 17.5 thousandths, which is a little bit more than half of that. So so what I'm going to say is that's 2 degrees, or roughly 2 degrees. All right, I'll figure it out exactly. It's 1.8 or whatever it is, right? And then we'll turn some of these little stumps on the lathe and put it all together and fix my friend's business. There's a little closer shot here of these kind of mangled studs here, and looking at this one here, I don't think I want to go a full inch here, so I'm going to cut them off at 3/4 of an inch. So I want to make the little replacements standoffs, identical. So, and I don't want to go all the way down to the base here. I don't know how thick it is in that area, right? So I think I'm just going to go 3/4 of an inch here, and that should get me out of the damaged area in this one here and this one without any trouble. So I'm going to mark those and cut those off at cut off 3/4. Very straight cut there, Mr. Actually, it doesn't look too bad from here. Okay. All right. I'm not going to be too hard on myself. Yeah, this is definitely zinc. And I'll retap these holes that are here. Well, that's a squeaker. I'll retap the holes so that the new piece can get added on. It's an annoying noise, isn't it? Can't stand it myself. Make sure you get it going nice and straight. I'm going to check it from both directions here. Lean on it a little bit that way. This is my, makes it harder to bozo a tap wrench here. Okay, I think that's hitting bottom there. Alright, so let's see. The set screws handy. Okay, there's our stud. So that's a set screw. I'll just tighten that up in there, and then that'll form a nice male thread to add the new piece onto. So. All right, let's see. I don't want any more sticking out than I need. So let's go a little more like that. So instead of, we're going to cut this angle, so this is going to be the big end and this will be the small end towards the chuck. So what I did was, and I didn't show this, I ground a tool that has the correct angle on it. And you can see my little scribe line there that I laid out. So what I did was I laid that line out and with an accurate protractor, then ground it. Then I checked it on the optical comparator and then adjusted the angle. Okay, so it's actually 1.7 degrees is the, oops, I don't know, different tool first, is the correct angle. And so it's, you know, sometimes it's easier to fuss with the tool and sometimes it's easier to fuss with the compound. So it just depends. So I decided in this case to do the tool, because I'm just going to do a big fat plunge in there and make the little thing, our little standoff in one whack. Hope that makes sense. So let's do this. Face first. That. Okay. I'll zero the Z-axis. This is kind of a weird rig. I have the chuck on it's just on a bushing, and I use this one for tapping small holes because I can, if I feel anything weird, I can just let go of the chuck like that, right? And like that, okay? If something weird happens. Alright, that should be deep enough. Alright, and then we'll tap when we, actually, you know what? Come on, Mr. Wizard. So we gotta do, there's more steps here. Sometimes it's hard to remember all this stuff when you're talking. Alright, so we're gonna zero this form tool against the end. Okay, beep. Alright, and then I'm gonna come in the width of the form tool, which is 3/4, 750, okay. Oh, I need to calibrate the diameter too, so let's do that. I'm gonna cut with my small end like that. Just gonna feed it in a little ways, like so. And it doesn't have the right clearance on the leading edge. That's why it's pushing up a burr, but we don't really care about that right now. So let's measure this. And then we'll calibrate the tool diameter. And then I'm just going to go to my number. Does that make sense? I'm just going to go to my small end number, 4875. Okay. 0.4875. Enter. Okay. Okay. So theoretically, we're ready to go here. Now we go into 750. There we go. And I'm going to go slow because I don't want it to shatter. All right, let's look at the, you know what? That's a pretty good shot. Let's just go with the flow there. Okay, our target number is 283 on the small end. It's cutting pretty good. So we're at 300 now, 290, 288, 84, there, okay. And theoretically, let's see here, we should be right at our 283 right here, 284, I'll take it. And then this thing here, this is just a little nasty little burr that we're going to take off. Let's check our rear, or our big end. So, oops, sorry guys, it should be around 323. Okay, it's a little small, 323. I did knock that burr off of there. We were looking for 327 was our theoretical, but we're 323. I think that's going to be okay for this thing. Put it this way, I'm not going to relap the tool anymore. So let's go ahead and thread that little monkey here, and you guys will get a look at this this chuck deal that I was trying to describe here. Okay, so we'll get up nice and close like that. Okay, and this chuck it's not keyed, or it's just in a in a bushing thing, so I can slide it axially like that, right? Okay, and let's see, low speed. All right, like that. Put a little liquid glove on there, and then I'm just going to hold this with my hand and stick it in there, right? So if for some reason I felt something alarming, I just let go of it, right? Or, okay, it's winding up, okay, so that's far enough. All right, and then I'm going to run it in reverse and do the same thing and come out. So it's kind of nice for that kind of stuff where you want some sensitive feel. Actually, we may run that down in there again and clear out those chippers. Okay. Okay. Went all the way down. And then you can go faster if you want to. Okay. Close enough. I'm pretty sure I'm through. Or deep enough, I should say. Okay, yeah, cut a little bit more. Okay, cool. Now, what I want to do is just kind of zero on that shoulder there, like that. Okay, that should be good. I see threads, I'm good. Okay. I just gotta take that little pip off of there, and then there's our piece. Rinse and repeat, and we're done. Let's do a dry fit up here first. Let's see how it looks. I'm gonna put Loctite on these so they don't come out, at least on this end here. And there's one of our spacers. Okay, it's a pretty good match. Actually, you know, I gotta grip that to tighten it up, so I gotta think about that. That one's got a little. Oh, you know what? There's a little bozo there. So this one was shorter. So interesting. I wonder if the angle was different on that, or it was just because it's a consistent taper. It was just a bigger area of the taper. I don't think that's going to hurt anything. So I got the lens here. We're just gonna pop that on there and see if I see threads. I see threads. I think I'm good. It's got a little gasket that sits in that trough too. All right, let's do a full. I'm giving him some slightly longer some screws so that he can get the gasket in there. And compress the gasket a little bit. All right. Things are looking pretty reasonable. Let's see, I don't want to crank that side down too much. I don't know how well this thing. I think this is an aftermarket light dealy bopper here. I guess you got a little bit of flexibility there to line it up. All right, well, I don't know how close these fit normally, so there's a little bit of variation. This is not machinist-like stuff here, so, but it's okay. Just quit looking at it. All right, let's do the final. I'm gonna Loctite it up and give it to Mr. Sam. And hopefully he'll be happy with it. I think he will, because he was stuck before. Okay, so this is some kind of Studebaker for all those that are wondering. I'm not sure what the model is. I'll see if I can get a picture of it for you guys. And now I want a little bit of Gronk on here. So what I'm gonna do is secure that and then give it a little bit of English there. All right. That should be good. I could have milled some flats on there, I suppose, but that would have been overkill. Oh yeah, that's tight. That feels pretty good. Okay, I think we're gonna call that quits. Time to get off the horse before we break something. This next group of things comes all the way from Ukraine, and by way of several handlers. And this was mailed to me by a guy named Vladimir Alisenko. Sorry, Vladimir, if I pronounced that incorrectly. And what we have here, and this one leaked a little bit here, and so I rebagged it. So there's a couple things in here. We got some scraping spotting inks, right, for when you're doing machine scraping. These are his formula that he's kind of come up with, so I'll be trying those out. But the main reason it's in the bag is these things here. Now these are some kind of air fresheners or something. I don't know what these are. They're melon flavored air fresheners from Ukraine, and I'll tell you, they are potent. So everything in the package smells like these things. And Vladimir also sent me this cool apron, and a scraping apron. And black is a great color for a scraping apron. All right, and that's his deal there, Biax. And he's got a flag, couple of flags on here, and I'm assuming this is the flag of the Ukraine here. I'm not positive. I didn't look it up. Sorry. Anyway, Vladimir, thank you very much. I know this was some effort to put together, and I really appreciate it. And it really humbles me when people go to that kind of effort to get something to me, you know, that they think I'll enjoy or that I'll make use of. So I very much appreciate it, and you know, that effort that you put in there. So we're going to try this spotting ink sometime here soon, and I'm sorry, I'm going to get rid of these. They're just too potent. For me anyway. In fact, I can smell it through the bag right now, so it's pretty intense. So anyway, thank you so much for sending this, and we're going to make good use of this. So this little lot here is it's actually kind of, I don't know, it's sad for me because these belong to a workmate of mine and friend that died recently. And anyway, they were cleaning out his office, and there was some stuff that ended up with me. And so these are a couple of the items here, so I just wanted to show them. Anyway, this is a friend of mine. His name was Jim Galvin, and he was a, well, what do you want to call it? This guy was brilliant, and I learned so much from him, and I did a little... it all started, he came over to my office one day and said, hey, Tom, I have a machining need. And I said, oh, okay, well, we'll just do it in the shop here. And he says, oh, no, it's for me personally. And I said, oh, okay, well, you know, what do you need to do, right? So he shows me this little job, and I said, oh, well, what's this for, right? And he says it's for one of my microscopes. And I said, really? I said, oh, you're into microscopes. And I didn't know this at the time. This is quite a while ago now. And so anyway, he said, do you know anybody that can help me out? And I said, well, yeah, I do. I'll do it. You know, I'll do it in my shop at home, right? And he goes, oh, okay. And so anyway, I did this little job, and you know, it was some adapter rings, you know, to hold some optics and some other stuff, and you know, it's a little, I don't know, it was a couple hours or whatever it was, right? So I bring it back to him, and I give him the job back, right? And he was just so appreciative, and thanked me so much. And he said, hey, what do I owe you? And I said, nothing, just nothing, forget it, right? And a couple weeks later, he comes into my office and he says, I have a present for you. And I said, really? I go, what's that? And he has a box with him, and he drops the box on my table in my office, and he says, I'm giving you a microscope. And I said, really? I said, wow. And he says, yeah, but you got to put it together. And I said, oh, okay. And he said, but I'll help you, you know, and I'll show you all the stuff, right? And I go, okay, great. So anyway, I got a microscope. And true to his word, he had taken apart dozens of this particular model. And anyway, so I rebuilt this microscope, took it all apart, cleaned all the linear bearing slides, and made everything operate, and all the little detents got fixed, and all the little things were. Anyway, and then he gave me a bunch of objective lenses and light sources, and basically I have a microscope that's probably worth $25K now, right? And you know, I can do polarized light, and I mean, just everything, right? So anyway, Jim is a good friend, and I helped him out a few times, and he helped me a bunch of times, and anyway, I got some of his stuff here. So let's take a look at this. So let's look at this one first, since it's probably the easiest one. This, you know, it's kind of a nondescript pair of Starrett calipers, okay? And these are old ones, obviously, right? And but what's kind of, and unfortunately, they don't have his name on them anywhere. I wish they did. That would be special for me, but I don't see any markings of his on here. So these will read to 1/1000th of an inch, okay? Now, what's interesting about these, and I don't know if you guys can see them, is we got a little dot right there, and then we have a little corresponding, you know, it's in line this way, a little dot on the frame here, or on the sliding part. And what that's for setting your dividers, okay? Which is a really neat feature, because now you can set your dividers very, very, very precisely. How do you like that, huh? So we go in the little hole like that. Okay. All right. So yeah, I didn't set it for a particular number, but you know, back in the olden days, when a lot of the machine work was done via layout, right? That was one way you could get an accurate, very, very accurate caliper settings, right? And describe a perfect circle or a perfectly sized circle. So pretty cool. That's kind of neat. And actually, I don't have any like that, believe it or not. But now I do, and they came from a good friend, which is this is the best thing, right? So now what we got here, this box is really hard to get open here. I want to be careful because what's in here is extremely sharp. All right. So what this is, and there's the word, this is a microtome knife, which is a very special kind of knife. My friend Jim was into microscopy, and so one of the things that you have to do, I don't have anything here that's any good, is sometimes when you have biologic samples, you want to take a very, very thin slice of them so that you can look at their structure. So light will actually go through the structure. And microtomes are designed to make very, very, very thin slices. In fact, extremely thin. They're actually quite impressive little machines. And there's an old, I think he had an old style one that was kind of a hand crank one that, excuse me, reciprocated the blade and then advanced the sample a little bit each time, or moved the knife. I don't know which. I remember him talking about it at one point, and he brought this knife in, which, you know, I don't know if it goes in the machine or if this is a handheld one. It must go in the machine. I think there's no way you can do this by hand. So how thin you can cut these. So with these kind of a normal microtome, right? You can cut things, you know, thinner than 50 microns, right? You can make slices in that kind of a range, or down to a few microns. And with ultra microtomes, you can actually make slices that are, in the 30 to 100 nanometer range, which is like super thin. And that's used in electron microscopy with biologic samples. So kind of cool. But let's take a look at this thing here, because this is what we have. And this thing, and I don't know, there's no way to define sharpness over video, right? I don't want to cut anything with this because I can damage the edge of this thing. But let's just say that this is beyond kind of scary sharp, right? And, you know, it's got a very, very steep bevel angle here. And actually there's a handle, I think, or this mounts in the machine here. I'm not positive on that. And let's see here. Let's see. I don't want to kill myself here on camera here. I think there's something underneath here. Yeah. Okay. Let's take a look. So there's the carrier for it to protect it. All right. So there's a little handle. Yeah. So now you can make a deadly weapon here. Oh God, look at that. That's I mean, that's pretty frightening. This is you know, this is straight razor, 10x straight razor kind of stuff here, and is that a guard? What is that? What is that? I don't know what that is. Oh, okay, so this is for sharpening here. This is for sharpening. I guess, I would guess that this slides over the, okay. So this slides over this and then sets that secondary bevel angle that you can just, you're probably just catching it in the light there. So you got this main bevel angle, then you got a secondary bevel angle that's very, very small there. So anyway, that's a pretty scary sharp chingadera there. So let's take this off and put it back in its protective environment here before I leak blood all over the place here. So anyway, yeah, microtomes are pretty cool, and they have the ultra microtomes use they're much smaller, the blades, and we're going to see something that's kind of along those lines in a sec. But the edge is actually made out of diamond, and so diamond they can hone and lap that and get that down to an extreme fine edge for cutting, you know, nanometer thickness samples. Pretty cool. So let's close that up, and then we'll take a look at this next one here, which is kind of neat. All right, this little guy here. So this is kind of along the same lines as that microtome knife or blade, and this is a cleaving tool. And now what I think this is for, it doesn't say that, but what I think this is for cutting optical, you know, fiber optics or optical fiber, and it fits in a machine. Let's get that out of there. If it mounts in a machine, okay, and is basically you put your optical fiber there, and it makes a nice clean cut. And you know, I don't know if I've never used one myself, and I don't know if the cut that it makes is you know, kind of splice ready or bond ready or whatever. So not sure, but I think you get a pretty clean cut now. So theoretically, and it says diamond on this deal here, that is a chunk of diamond there, and it's actually a pretty big chunk of diamond. You know, as far as diamonds go. Excuse me, I get some hiccups going here. So it's pretty cool actually. So and you know, I run my finger over it, and it feels like really sharp. Okay. It's not a microtome blade, but it's a cleaving blade, so it's going to have a slightly different angle to it. And what I'm thinking is, and I can visually see some little, you know, and you probably can't see it on video, but I'm looking at it, and if I catch it just right in the light, I see some little anomalies on the edge. And let's see if I can. Yeah, if I just just slip my fingernail along that, it catches some little divots. I'll call them divots, okay? So what I think I'll do is go put this on the microscope that I built with Jim Galvin and see if we can get some imagery of that diamond and that edge. So what do you think? That sounds kind of cool, huh? So it's kind of a nice tribute to Jim. We'll use the microscope to look at a diamond that he left for me in his stuff in his office. So anyway, let's go try to. I'll get that set up and then we'll get the camera over there. So this is the microscope that I built with Jim Galvin, and basically he brought me a big box of parts, and said, here you go. And so what he was trying to do is he wanted one of these in its most complete state with every possible accessory that they ever came with. So to do that, he had to buy a lot of what I would call carcasses to get certain parts off of so that he could have the most complete and best unit. So he was prowling eBay for years buying these things, and so consequently, anyway, he got what he wanted, and he has the most complete, Optifot that I've ever seen, right? And but in the process, he had parts for probably 5 or 6 others. And anyway, I ended up with some of those parts and was able to put together a complete system that's actually quite nice. And so that's what we're going to do. We're going to put our little diamond cleaving blade in here, and if I have a video camera here, so I'm kind of getting the image kind of. So I turned off the lights in the room, which seemed to help here, and so this is the carrier, and then this is the diamond, and then this is the edge here, and you can see there a little bit of damage. And let me I'll move it around a little bit. So there's the corner, right? And then if I slide it down, you can see the little notches in the edge. There's some big chinguses there. I think that's what I felt with my finger there. Oop, wrong way there. Let's see if I can sharpen that up a little bit here. There we go, that's pretty good there. So yeah, you can see that that edge is pretty severely damaged there, right? Now we're lighting it just from the top here. So there's probably some combinations of lighting that might improve that. And that's one thing in microscopy is, you're fiddling around with some parameters to get the best view. Now this particular software, I can take images, I can take measurements, things like that, which is kind of handy for machinist nerds. So I'm gonna kick it up to the next magnification, and I'll turn the camera off for a second because it'll take me a minute to probably get it dialed in. So, all right, we're getting close here. Let's get some focus going here. All right, that's pretty good. And then there we go. That's those little broken edges. So I had to fiddle around with the sample a little bit oh yeah, that's pretty cool. Yeah, it's definitely broken. Looks terrible, huh? So that's one thing with microscopes, that that you can make anything look bad. Let's just put it that way, right? So that's that diamond edge. That's so there, but you can see how good. There you can see some lapping marks in it up here, right? You can see some crisscross from the lapping. But when you look at the actual edge that's intact, it's actually fantastic, even at this high magnification. So, actually, I don't know what 10 plus. This, yeah, you know what? I'm not sure what this magnification is. I'd have to look at the thing. I can't see the objective number. So anyway, I'm nerding out here. Sorry. The actual edge that's intact is actually spectacular, right? And actually quite good. So there's a corner that's dinged up right there, and then we'll slide down. Look at the other. Oh yeah, there's the other end there. That's a chowder fest there, huh? Yeah. Oh yeah, that's pretty cool. All right, well, I think that's enough nerding out. Anyway, thanks, Jim. I appreciate you giving me this stuff and hooking me up with this microscope. So I hope you're having fun in the big shop in the sky. Well, there was a whole bunch of folks that were kind of pissed off that I didn't show this little trailer hitch arrangement here. I had mentioned it, and I guess I forgot about it when I was doing the rest of the video. But what this is clearly, we're at the lathe here, okay? And this is the carriage, and then this is the tailstock here. And what I've done is I put a bracket on the tailstock, and then this bracket kind of does double duty. It protects the scale here, the DRO scale, from the tailstock slamming into it. But it also is my, let's see, make sure. Oh yeah, that's brilliant, Tom. You can really see that well, can't you? Okay, let's back up just a whisker here. Okay, I'll back up into this. Okay, and then you can couple these together, all right, and drop that in. So now my tailstock is kind of coupled up. Now it's got a little bit of play, but usually it doesn't matter because you're going forward, and then you back up to clear. So the advantages of this is now I can power feed the tailstock if I want to. And the other neato thing about that is now I can use the DRO to keep track of this position, my drilling position. So I don't move the quill in that case. I just lock it, okay, like so. And then I just use the carriage to peck with. So I can go back to a particular peck depth and then pick up. Or I can drill a precision depth, for example, and so there's some things that you can do and that are kind of neat. So that is the trailer, the mystery trailer hitch, and then I just uncouple and drive off. So sorry about forgetting about that, folks, but there it is.